Almost every SQL statement you'll construct in Oracle Database 19c will have one or more literal values, also known as constants. You'll use them in almost all clauses of a select statement, as well as in DML statements such as insert, delete, update, and merge. I'll show you how to build them, how to use them, and the rules around where they are permitted. What is a literal? From the dictionary's perspective, it's the basic meaning of a word or phrase. As a noun, it's a misprint of a letter in printed text. Well, in Oracle it's a noun, but not really close to the dictionary definition. A literal is a fixed value, a constant, not a variable or a value in a table column of any given row. Some examples are shown on the slide. The numeric value 11.5 is going to be 11.5 no matter where you use it. By now, you've probably figured out that literals can exist for just about every Oracle Database 19c data type, and you'd be mostly right. The most common types of literals you'll use are string literals, numeric literals, date literals, and interval literals. Interval literals are related to date literals, but they represent differences in time, as the word interval implies. I'll show examples of all of these in the following slides. String literals are the most straightforward. String literals can be any sequence of 0 or more characters surrounded by single quotes. As in the examples, you can have a string literal with nothing in it, the equivalent of a null string. If you need to include a single quote inside the string literal, put two of them together. In the select statement, I have two columns in the output. Both of them are string literals, which I could also combine into a single string. If I don't reference any table columns, then it's typical to use the dual table when there are no columns to reference. Numeric literals are a bit more complicated, but as the old saying goes, you know one when you see one. There are three subtypes: integers, numbers, and floating point. Integers differ from numbers in that they have only the digits 0 through 9. In other words, no decimal points or scientific notation. Floating point numbers usually have a decimal point, and sometimes they have an E to indicate scientific notation. Floating point is really about how it's stored internally in binary with the exponent. Here are the syntax diagrams for integers, numbers, and numbers' more complicated cousin, floating point. Integers can also have a sign, of course, positive or negative. Numbers start out as integers with an optional decimal point. If there is a trailing E with one or more digits, then the number is in scientific notation, and the number after the E is the exponent. Note that scientific notation doesn't automatically mean that the number is stored as floating point. But if the number is very large or very small, using scientific notation makes numbers a lot easier to work with. Date literals are sometimes not what they seem. The four date-time data types are date, timestamp, timestamp with time zone, and timestamp with local time zone. The biggest difference between date columns and timestamp columns is that the date values are stored with a precision to the nearest second, whereas all of the timestamp data types can store date-time values to the nearest billionth of a second, optionally with a time zone offset. Date literals use the ANSI standard for date and timestamp literals with the date or timestamp keyword, followed by a string representing a date in a very specific format: year, month, and day, with a dash for date, and the same for timestamp with hours, minutes, and seconds, with an optional numeric or text time zone offset. The example constants in the first column are valid. The sample select statement shows the timestamp constant in action. The values in the second column are invalid. The first invalid example shows a date constant, but a date constant does not support a time component. The other two examples show a string containing a date, which may implicitly convert to a date or timestamp value given your NLS settings. But when in doubt, use explicit conversion. The example shows an explicit conversion of a string that represents a date using the toDate function. Interval literals are very similar to datetime literals, but they represent time periods, not absolute dates or times. You'll use them to convert a string or column to a time period, which you'll often use in date arithmetic when adding or subtracting from a date value. The first one converts years and months to either years or months. The second one converts days, hours, minutes, and seconds to days, hours, minutes, or seconds. The examples make this clearer. The first example is a time period of 8 days, which you can add or subtract from any date or timestamp value. The second example is 13 hours and 10 minutes, or a total of 780 minutes. The third example uses a dash to separate the years, 2, from the months, 5, which adds up to 29 months total. The last example is a select statement that adds the date value 12/15/2019 to the interval equivalent to 29 months in the previous line, returning a date value of 5/15/2022, 29 months after 12/15/2019. Finally, you can use a numeric literal in the order by clause. It's positional. In the example, the order by uses the fourth column to order the results, since I didn't want to retype the word department ID. There is a small catch, though. If you decided to add or remove columns in the select clause, be sure to change the numeric constant in the order by clause. Otherwise, your results will sort on a different column than you intended. I've told you literally all I know about literals in Oracle Database, and that's what you'll need to know about literals. There are 4 types: numeric, string, date, and interval, and each has a couple of subtypes. You can use them by themselves or when constructing expressions. Be careful with date literals. A string may look like a date literal, but the only true date literal has a very specific format. A special case of a literal is when you use a numeric literal to reference a column number in the select clause in the order by clause. It saves some typing, but it can be hazardous when you modify the select statement.